All right. So this is the formula to construct a confidence interval whenever you have a mean using our t-values. We're adding and subtracting, and that number that we're adding and subtracting is called the margin of error. Hey, Will, can you close the door, please?
Yeah.
And so today we are actually going to find the sample size to determine how small the sample size can be to stay within that margin of error. So I don't know if you guys remember, like, we would find a value and then we have to like flip the fraction. Do you remember doing this with proportions? You know, say we had our sample size, and like if we flipped the fraction on one side, we had to flip the fraction on the other side to solve for n. That's what we're going to do today. Now, we have to know everything but the sample size. We have to know the standard deviation, we have to know the margin of error, and we have to know the critical value. So do you guys have your t-tables? So let's go ahead and pull those out. And you're going to need your calculators today as well. Hang on, I didn't mean to move that. I've just lost something. Or I just lost it. Oh, there it is. All right, so in order to find your t critical value, all right, I want you guys to take a look at your t-table, and I want you guys to look at the 95% confidence level at the bottom. All right, how do we determine which number to use for our t in this 95% column? What else do we have to know in order to use the t-table? All right, where do we get degrees of freedom from? Okay, do we know what n is? All right, but isn't that what we're trying to find today? So if we don't know the sample size, are we going to be able to use this chart? No, because if you look, if I told you to do something at a 95% confidence interval, you have like an entire list to use. And I mean, if you have something, look, the top number is 12, the bottom one is 1.96. I'm going to say, what do you guys think about that? You know, say, do you remember what 1.96 was with 95%? Wasn't that the z? For, okay, I want you guys to know, do you see at the bottom where it says infinite? These values right here are the z's for an infinite. So if you don't know the sample size, we just use the infinity. So we're going to be working with this bottom row today. Now I'm also going to show you guys how to do this on your calculator as well. But since we do not know the sample size, because in order to find the t-value, you have to know the degrees of freedom, which requires you to know the sample size. Since we don't know that, we actually have to use the z-table or the infinite on the t-table. So, oh, that's a really bad infinity symbol. No, so I can make it. Yeah, we'll use the infinity symbol on the t-chart. So instead of using t today, we have to use z, because z is what we use when we don't know the sample size. Now, we could get the z-charts out, but there's really no sense in getting the z-chart out whenever it is on, that infinity is on your table. So we are going to plug in what we know. So we will find our z, we'll be given our standard deviation, we'll be given our margin of error, and then we solve for n. All right, are you guys ready to try a couple of these? Wait, okay. You're good? Jacob, are you still writing?
Yeah.
Okay, let me know when you're ready. Okay, so I'm just going to give you guys some information. I'm not going to make you write out all of the word problems, but if you are given, oh, don't worry about that frog. That's actually, it's a back of an old paper that I thought I was going to have you guys do. All right, let me see if I can. All right, so we are going to work with, on this first one, we want a 95% confidence level. And in this case, we know that the standard deviation is 300 milliliters, and we want our margin of error to be within 100. All right, so our margin of error is what we add or subtract from the formula, but instead of t, we're using z. So this is what we add and subtract to the mean. We want this to be less than or equal to, and I'm just using m for margin of error because I don't like to write me. I don't want you to think it's two variables. I'm just going to stick with one. So margin of error, let's just use m. All right, so let's plug in what we know. All right, so the first thing we have to know is our z. Do you guys have your table? You're going to say, where is the z at the very bottom at 99% at infinity? What are we going to use? 2.576. And then we know our standard deviation is 300. We want to know the sample size, so that's our n, that's our unknown. We want that to be less than 100. All right, so we have to solve for n. Let's see, what's the first thing we're going to do? And so do you guys remember the very first thing that we did whenever we solved these in chapter 18? Okay, we need to divide the z-score first. Or just the z-value. So we're actually going to divide the 2.576 over Now, I'm not going to put stuff into my calculator right yet. All right, we need our n in the numerator. So this is what we were talking about earlier. We need the n in the numerator. So it is totally okay to flip the first fraction if we do what? All right, we flip the second fraction. And what else do we have to do? Yep, we got to flip the sign. We flip everything. All right, now we can start solving. To get n by itself, how do I get rid of that divide by 300? All right, we're going to multiply that 300 over. So now we're ready for our calculator. So we are going to take, I want to make it to where you can see. So we're going to take 2.576, divide that by 100, and then take that answer times 300. And I got 7.728. Say this one ended up being a terminating decimal. If it's a repeating decimal, just keep it in your calculator, because then how do we get rid of this square root? All right, then we have to square that number, so then you can square your answer on your calculator just by hitting the squared button. So it's telling us that we need a sample size bigger than 59.7. So what's the smallest sample size if we round up? All right, the smallest sample size is 60. So 60 would be the smallest sample size. So I know the algebra part is a review. We've done these before, but I just wanted to make sure that we had some different practice. I think that it's a little bit easier to type in because there's less decimals with means versus proportions. All right, I've got another example here somewhere. Here we go. You say, do you guys have any questions on that one before we try another one? All right, this next one, let's go with 90% confidence level, and I'm going to abbreviate confidence level. And let's say our standard deviation is 400 calories, and we want our margin of error to be within 300 calories. Hey, do you guys agree with this? Do you think that's a little nicer to see versus that? So all I did was I divided the z over. Is it okay to just go ahead and plug in the z on the other side? Say if you guys are okay with that, so am I. All right, so standard deviation is 400. Sample size is unknown. My margin of error is 300. But what am I going to plug in for z? If we look at the table, we go to 95 or 90% confidence level. What am I going to plug in down here? I'll say you guys have your table. What goes in there? 90% on the infinity. 1.645. All right, then we can solve. Do you guys want to try to solve this one on your own? I see most of you have already started. Like, I can see that you guys are working, but I'll give you guys some time. Did you guys get a big number or a small number for your sample size on this one? I'm going to say, I also got a small number. All right, are you guys ready to see my work? What do you guys think? So I plugged in what I knew, I flipped my fractions, flipped the inequality sign, I multiplied my 400 over. So then in my calculator I typed in 1.645 divided by 300 times 400 and I got that 2.193 repeating. And then I took my answer that was right on my calculator and I just hit squared and I got 4.1807. I really got to figure out why that doesn't work. All right, so I want to show you guys something today. All right, do you guys have your calculators out? I want to show you there is a way to find T's and Z's on your calculator if you happen to be somewhere and you don't have a T or a Z chart. If you are missing your chart, you can find these on your calculator. So I want you guys to get those calculators out. And if you have a calculator like mine, if you have a TI-84 Plus, I want you to follow with me. If you don't have a TI, if you have the color edition, yours can do a little bit more. I will have to show you that in just a second. So if you have a calculator like mine, let's do those first. All right, so if you want to find T on your calculator, you go to, and I'm going to, I'm going to take the black and white filter off because it actually shows up for the virtual students better like this. So if you have questions and you want me to actually look at yours, I can. So if you want to find T, and we still open up that distribution menu like we've been doing for like the normal CDFs, normal PDFs. So we do hit the second and then we go to the distribution. Then you actually go to option 4 where it says inverse T. That tells me I need to find the T. So you go to inverse T. Now area on this is your confidence level in a percent. So like this?
Yeah.
And I can turn this back into black and white so it shows up better for you guys. So whenever you are typing this in, your area, you type in the confidence level as a decimal. So if I told you to find a 98% confidence level, you would type in 0.98. And let's just do degrees of freedom as 6. And then paste that in. So if you, and then your degree of freedom is whatever n minus 1 is. So on this one, if you can see, and I'm going to write and then I'll move my calculator back up, a 98 degrees of freedom, or 6 degrees of freedom at 98% is 2.6122 and it repeats. Now look at that on your chart. Hey, the side conversations really need to stop. I'm only going to show you this once. So if you guys look on your chart at 98% and 6 degrees of freedom, where are we at? Okay, it include. Okay, I know exactly what happened. You have to subtract the tail. All right, so do you remember when we talked about 98% being like this? In order, we have to subtract out the tail. So you do have to subtract out the tail if you don't have, to find your t, you subtract the tail out. And if you're looking for a z, you have to add the tail in to type these in. You know, say the calculator is new for me. I've never done it with a calculator. I actually just discovered it on YouTube about 20 minutes ago. So you do have to subtract the tail, because if you see it went over to 96%. So you do have to subtract that tail, because whenever you're doing your t probability, it does include that all the way down. So in order to get that whole central, you do have to get rid of that tail. And then on the z chart, you have to add the tail in. So if you're finding the t, you do inverse t. Now, if you want to find a z value, you do that same menu. You are in that distribution menu, but is it option 3? Option 3 is inverse normal. And your area is your confidence level, but you add your tail in. And then you leave your mean and standard deviation as 0 and 1. Because on a z, 0 is the mean and a positive is above average. So you leave these alone. You know, say, and honestly, I would rather you use your chart, but these are just like a worst case scenario if you don't have a chart. You do have the ability to do that. And I'm going to just show this on the video. So for a 98% confidence level, and then I can turn it back to black and white for you guys. But on a 98% confidence interval, you have 1% tails. So you actually type in 0.99 in as your area, and then do 0 and 1. And that gives you the exact same number as what we have on the chart. All right, so now if you are looking, let me see, let's zoom out. So if you're finding t, you add the tail in before you type it in. If you're or subtract it. If you're finding z, you add it in. And then you leave your mean and standard deviation alone. It'll automatically have 0 and 1 in there. You just leave it. And it will it'll give you those answers. But I am not super concerned about the calculator, because you will be given a chart, and the T charts are super easy to work with. So that's what I would recommend, just staying with those. But this is just in case something doesn't work, or if you don't have a chart, you do have a way to find them on the calculator. It's just not as easy. All right, so we are done with chapter 19. You know, say the calculator stuff that I just showed you will not be quizzed or tested at all. You'll have charts to work with. But I do want to let you guys know, wrong class. All right, so we will be reviewing on Monday, quizzing on Tuesday over this. So you got your T intervals, which I've already, if you haven't done, I've already put it into the grade book. Most of you guys did have that assignment done from yesterday, but it is due tonight at midnight. And then your sample size is due Monday, but you guys have the rest of the time to work on it today. So the last 2 assignments, and if you didn't like your score from yesterday, you can redo it until midnight tonight. And I was just putting those in as they came in, and if they change, I can change those as well. So do you guys just need a nap or what?